Okay, Julia dear.
Hello.
You're going to do the experiment for solvents.
Yes, first we're going to see the evaporation rate.
You have your safety glasses on? Yes. Do you have your impermeable nitrile gloves on?
Yes.
Okay, well, don't get any solvent on your hands.
Okay. I should be wearing gloves.
Well,
Disclaimer.
as long as you wash your hands afterwards, it'll be all right.
Okay.
Okay, let's start with here's the...
So we're weighing these and seeing how fast they evaporate. We'll be doing they're all compared to this one. However, we'll be doing the acetone first because it's so...
Okay, by this one you mean the butyl acetate.
Yes. By this one I mean the N-butyl acetate.
Okay, butyl acetate is the reference.
Yes,
Good.
that is our reference, but we'll be doing acetone first just because it evaporates so quickly.
Okay, let's see how acetone
first,
evaporates.
We're going to be putting it in this to have even surface area. So let me zero that.
You're going to weigh 10 grams, huh?
Yep. There, now it's zeroed.
And this is acetone? Let me see.
Acetone?
So it is.
It says it's acetone. Let's hope it's acetone. Okay, so 10 grams.
Now we have a fire extinguisher handy just in case? Yes.
Yes. Oops.
Okay, if you go a little past, that's all right. Just write down what you actually put in.
Yep.
13.5, say plus 3.5.
Yep. And hold on. So now we swirl it. Like that. And there.
Okay.
Okay. So see, it's already...
13.1. Where's your...
It's 8 pen... Okay, so at 13.0 it's 8:14.
Where's your stopwatch?
Right here.
Okay.
13.0 was 8:14. And now it's already... It's still 8:14. We might have to go into seconds.
That's right.
Okay, so it's 12.8. So it's 8:15 exactly. Oh, 2 seconds. Okay, fine. 8:15 in 2 seconds was 0.7. So 8:15 in 11 seconds.
Okay,
So
it just went to 12.6. So you just lost 1/10 of a gram.
yep. So it was 8.
Whoops, 12.5 again. You better do that by
8:15. Yeah,
better do it by seconds.
seconds it is. So I'm gonna do my stopwatch. So as soon as it hits, okay.
There, 12.4.
So 12.4 and okay,
There.
so it's 9 seconds exactly.
Okay, just write down 9 seconds in.
So just 9 seconds.
9 seconds. Okay. Nope, there's 12.2. How many seconds now?
5.
Okay, say 5.
5 seconds.
12.1. Okay, how many seconds?
9 seconds.
9 seconds. So the average... Oh, no. This has to be on acetone.
That is on acetone. That is right.
Okay, so you just copy the data there for acetone.
Okay, so it started at 8:14, we'll say.
And just say 9 seconds.
I'm sure this was 9, but I counted just 5. 9 seconds.
Good. Okay.
And it keeps going down.
Yeah. Okay, so now
I'll put a single line through that to know where I messed up.
Okay.
Single
should
line.
be videoing this.
Yeah, just a single line.
Okay. So now let's look at the butyl acetate.
Butyl acetate, let's go.
Let's put that into the hazardous waste container. That would be this one. Not over the book,
Not
maybe
over
over
the
the... All right. And then let's wipe it off with the paper towel. Where's the paper towel?
Last one I saw was over there, so it's not there anymore, so we'll be using this.
Okay. It's paper.
It's paper, it's a towel, there you go. Okay. We'll clean this. Okay.
Okay, now we have enough air movement in here to we're not getting asphyxiated by the... Oh, there's the butyl acetate right there.
Okay. And butyl acetate. Here we go. So let's zero this again. And I'll set my stopwatch. I'm gonna switch. I'm weird and I have my stopwatch on the other side, but I will switch it for this. Here. Okay. So I can record and write it while watching at the same time. Okay, so.
Okay, so you re-zeroed it.
Re-zeroed it. And now I'll try to put 10 grams.
Add 10 grams. Or the neighborhood thereof. There, you got it. Oh,
0.6.
excellent. 10.5.
Okay.
Good.
And I'll swirl it just to get surface area.
Yep.
See
Get
it
all
swirling?
Okay.
Perfect. Still 10.5. Okay, 10.5. And I will start stopwatch. Okay.
Okay, I'll be right back. Okay, how's the experiment coming?
Well, we're still on butyl acid, right? This one, acetate. Butyl acetate. And, well, it went up to 10.7 and then took 4 minutes to get down to 0.6. 10.6.
Okay, so how are you going to record this?
Well, first, I use whiteout. Second, I wait for the whiteout to dry, and then I started at 8:19, and then I'll say for the first part, it took 4 minutes, actually 4 minutes about exactly. And then we're still waiting for the second one, and I'll write that in, and then after that we'll wait for the third.
10.6 still.
Yeah, because it's 6 minutes, so in another 2 minutes, we hypothesize that it will be another 0.1 gram off.
Okay, well,
evaporated.
let's wait and see.
Okay. Hi. So, while I wait for 2 more minutes... Oh, it changed. Okay, so that was about...
About?
No, sorry. I'm going to say about 3 and almost 4 minutes.
We're scientists. We don't do this almost.
No, because it was 5 milliseconds away from 7.
Well, then call it, write it. Oh, you can't write it down until the whiteout dries.
Yeah.
Okay, so the first one was 8 minutes.
It was 6.
No, the first one was
6 minutes and 55 seconds.
Good. That's how you want to do it. 6
Okay.
minutes, 55 seconds. And what was the first one? 4 minutes exactly.
Mm-hmm.
Okay, good. That's how we want to do it. Numbers are just numbers. They're not magic favorite things.
I know.
Ooh, my favorite number is 6. I'm going to put down 6.
It's actually 3. Okay, so while I'm waiting, it changed for 7:42.
All right.
That was interesting.
Good. Well, that's how this test is done. It's not too accurate. That's part of what we want to know.
Has to do with air currents and moving around and... Okay,
see,
so
the solvent evaporating will actually cool off the plate. When you cool off the plate, you actually, what?
Heat of evaporation.
Heat of evaporation cools off the plate, and if it's cool, what do you think evaporates faster or slower when it's cool? Slower, because the molecules move less. They jump around, jump out of the puddle with less energy.
Yeah, because the hotter the plate would make it have more energy.
There you go. Okay.
And while I'm waiting for that to change, I'm opening that
Elvasite, acrylic resins. Good.
Ta-da! It's all open and sticky.
Okay. So where's your beaker?
My beaker is right here. Ta-da!
You want to label it?
I will label it. Oh, 9 minutes flat. Change to 0.3. See, I had a pen this time.
Okay.
Okay, so this is going to be our solution 17F. So...
This is dry. I think you can write down before you forget all those numbers.
Oh, good.
You should write them down right away, of course.
I know. Okay, so this is 8:19 I started. This was 4 minutes flat. This was 6 minutes and 55 seconds. And this was 7:42. Ta-da!
Great. Okay. Now you can put that all into the same wash thinner bucket.
Yep, I will into the...
If there's any
Always bucket.
left.
But
Is there any
first,
left?
there is a little left.
Okay.
But first I'm going to write down
Oh, okay.
solution 17F, and today's date is the 18th of February, so 7/18/2014.
It's 2:14.
2/18 February. Did I put 7?
Uh-huh.
I didn't do that.
Thinking about your birthday.
No, I didn't do that. Actually, today's Rachel's birthday.
Oh, okay.
So I was thinking of a birthday, I just wasn't thinking of my birthday.
Okay.
So I said 7.
Okay.
I think, yeah, okay.
Good scientist doesn't let birthdays influence her.
I may be a scientist, but I'm a person scientist, so.
Okay, you got it labeled right. Now, we want to weigh up this formula 17F. Xylene, acetone, and aldosite. Okay.
Great. So first the xylene, which was right here. Okay, I'm gonna put, so I can use this balance, I'm gonna put this into the hazard waste container.
It's actually not the hazardous waste container anymore. It's the wash solvent container.
Yeah. The wash solvent container. And I'll dry this.
If it's a hazardous waste container, it means that we have to label it.
Oh.
And it still has use as a wash solvent, so
Okay. Well,
it's part of the procedure.
wash solvent container. Dry all this. There.
Okay, now I actually don't need that pan anymore.
You're right, we don't. You just need this now. Okay. So 0.
Zero it.
And now we will have 30 grams of xylene. Oh, by the way, this is a different way to take. Got it. This is a different way to record the notebook, rather than the way that I usually do it.
Yeah, this style here is by columns, going across the page to the right.
Okay. There. So see, make sure you get some of the drips off, and now, 0.1. 20 grams, but there's only on the balance.
So usually you pour it out of a beaker.
Yeah,
Pour it into the beaker, then you won't drip.
that makes me happier. Well, I don't need that much more. But, yeah, that makes it a lot easier, see? And we need 30, so. Ta-da!
Excellent.
And that 0.1, remember, is on the actual,
Take some paper and wipe the balance.
yes.
And cleans the balance at the same time.
It does clean it out. See? Worked out for us.
Our solvent's wonderful.
29.9.
Okay, it's close enough.
Nope.
One more drop.
Drop, 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 drop. Darn it. Where's the beaker? There it is. Drop. Ta-da! 30. Okay, yeah, I know that I didn't really have to do that, but it's always nice to have it, then you don't Then you actually have it. Okay. So
Yeah,
now
check off your 30.
you will check off the 30 because we put it in. See, 30, 30. There you go.
Good.
Okay, now we have, let's cover our xylene. Now we have our acetone again. Alright.
Pour it into the beaker first.
Beaker first. And I'll zero that. Okay. Remember, this is evaporating fast, as you saw.
Yeah.
Acetone is 40, so... Oh, okay. 36.1.
A lot of good your safety glasses are doing you on your head.
You didn't see that. I had them on the whole time.
I have it recorded.
Shh. There we go.
All right. Excellent.
And that goes in there.
You could just put that back in the...
No, because I had the xylene in it.
Probably true.
Because they're all going into here, but they're not going back into that.
Okay, generally, in industrial chemicals, we put it right straight back in because little...
Acetone? Check.
Okay. Now we need to put it on the mixer.
Yeah, see the stir.
Can you put that... do you remember how to do that?
No.
Other way.
Yeah, okay. That's what I thought I was going to do, and...
Needs to be tighter, that's all.
Okay. Oh, good. There we go. Tight.
Yep.
Okay. Now we put it on here.
That'll probably splash all the solvent out.
That won't be good, so we should either change the gear or...
Pour the acrylic right into it first. Usually it's not done that way.
Okay, so
Yeah, we could put it on a lower setting.
we could. But in this case, we're going to put it...
Okay, here's the lower setting. Take this, push it down. Take that, push it down. And push it down one more. To make sure it's a real low setting.
That is a real low setting.
Now let's see how slow it goes. Okay, we go down to the very lowest setting. That feels pretty low.
Think that will work?
See if it splashes it all out. I don't think it will.
Nope.
Perfect. Okay. Now let's weigh the acrylic into a paper cup, and then we can pour it in under agitation.
Great. Okay. So paper cup it is. Here's a paper cup. Here's a zeroing. I knew I put it somewhere important.
Yeah, hard to find.
Hard to find. Okay. Ta-da!
Might want to use this cute little scoop that we have, right? Scoop. Right there.
Oh. Oh, that is a cute scoop. Hold on.
That's and get the powder off of it.
Yeah, that's what I say. We have to clean our scoop. But that is a cute scoop.
It's a that's a cosmetic scoop.
I like it. I like it a lot. Okay, see, cleaning the spoon, cleaning the cute scoop.
all nice and clean. I have to pick that up. Okay, so our nice new okay, so we want to see 30 grams.
Okay, 30 grams it will be. We're almost out of battery, I think.
I don't know. Want to get the other camera? How much more battery do we have?
It says 1.2 minutes.
Oh. I can go get the other camera. You can pause it while I'm scooping. That was pretty cool.
You got it, 30.0.
That was kind of cool because I took one scoop out and it happened to be 0.7, and then it got to exactly.
Okay, so let's add it to this mixture of strong solvents.
Okay.
Xylene is a very good solvent for acrylic, and acetone is a very good polar solvent for just about everything.
When in doubt, use acetone. Okay, so we turn it on here.
Yep.
Then.
Very nice.
There you go. All added.
Okay, so we'll let it stir for a while. Bring this plate up. And hold that plate in place. Okay, we'll come back to where it's probably going to turn viscous after a few minutes, so I wouldn't leave it stirring like that. I mean, I hang on to it, by the way.
Alright, so see the solution 17, F, right? F. It's already it's not completely dissolved yet, but it's already more viscous. Like, it's not splashing up onto the sides anymore. You can still see granules. Oops. I mean, you can still see granules, but, it's all flowing a little more thicker. So it's working. 34 minutes on my, it's been 34 minutes on my stopwatch. So.
Okay, so it's been mixing for 34 minutes. Well,
It's probably less than that, but yeah.
it looks like it's just about homogeneous. Do you have a test?
Yes, so.
And hang on to it when you stick it in
hang on to
there.
it. So we're gonna, like that.
Yeah, for that
Put
reason.
it like this, and see, we think that this is just air bubbles. Like, see if they pop. Oh, look. Yeah, we think those are air bubbles.
Did they go away when you blew on them?
Most of them went away, yes.
Okay.
Except for that one. Oh, but you can see that those aren't particles.
Okay, well, if there's one or two particles, we can live with those.
Yeah,
just a
but
demonstration.
they're still, they think they're air bubbles.
Hold it right there so I can get it right in the sunlight.
Oh, okay, hold on. Can you see it? See it?
I'll hold it still.
Yeah, they're popping. They're air bubbles.
Okay, take your word for it. Okay, good. Then let's shut off the mixer.
Okay. Mixture off. Command.
Put it down. Now, what do the instructions say to do?
Now, the instructions. Las instrucciones.
Take 10 grams of this. What we'll do is mix this, push this up so we can spin that off.
Oh.
Then, like that, and spin it off. You don't have to use the spatula anymore.
That's a lot easier.
Yep.
There we go.
Okay, that's good. Now we take 10 grams of that.
Yep.
Label your container. Wipe that off.
Thank you. Because of all the acetone, it dries really fast.
Yeah.
So, guess what? Acetone evaporates really fast.
That helps.
Okay, so spatula's dry. And clean. So now we want...
Did you check off your 30 grams?
Yeah.
Okay.
Okay, so now we want to do a kind of a drawdown, right?
No, we'll draw them all down at the same time.
Oh, all at the same time? Sounds good to me. So now we want 90. Wait.
Yeah, you want to take 10 grams and put it, because see, since you need 17F, which you just made,
Right, I have 17F.
you need to compare 17F by itself. So
Okay.
put in a paper cup 10 grams to be drawn down.
Sounds good. And this
Because
one
you made
will be-
100 grams,
Yes.
and you only need 90 for this next one. So that means
so
you take 10
here
grams out.
is solution 17F to 18. Okay, so solution 17F for us to work with.
That SOL stands for solvent,
Yes.
because this is a solvent study.
Oh, okay. That solution.
So you want 10 grams.
And
You got it.
10. There we go. 10
Perfect.
grams.
All right.
Sounds good to me. And we'll wipe the side that had dripped off. So this is a solvent study.
Yes.
Oh yeah, look, solvent. See, it wipes solvent right off.
Yeah. It's one of the things solvents do. Now you put it back into here, and we're going to add another solvent to it. And then we'll be calling it 17G.
Okay.
So change your label in here.
So 17F is going to become 17G.
Be nice to show the camera.
It's now a G.
Oh, okay.
Are you stuck? Thank you. Okay, great. So now we are going to add, okay, so see, I have my 90 because I just put 10 in there.
Good.
Uh-oh. It evaporated, sorry. Now we're going to put odorless mineral spirits, which is this one. We're going to put it in that one, which is 17F.
Okay, 20 grams.
So we'll put this right here for the drawdown.
You can use that to transfer with. Yeah, you can you just put that right up there, zero it. Good. And then put in 20 grams.
Odorless mineral spirits. And we will make it so it flows over that way.
Remember, this is called F-can.
F-can, yes. So 20. 20 goes like...
There you are.
20.3.
Good.
Okay. So I could, since this is the only one, I could get that 0.3 out, but I'm just going to say plus 0.3. 0.3. Right there.
Okay.
And then I will add it and then check it off.
Okay. Now add it while you're mixing.
While it's mixing, yeah.
Now, since this is a bad solvent, we'll see what happens.
Okay, so you can see it. It's a bad solvent, so...
Hang on tight. You don't know what bad solvent's going to do. Whoa, look, it's turning
look at
white.
that.
Turning nasty looking.
Yeah, look, it's already, it's not going to overflow. I think it's good, but look how much it... Okay, maybe it is. Wow. What was it? Wow. Oh, look at that. It has gel. Do you see?
Yeah.
Hold on, put this...
It kicked it out of solution.
Yeah, I kicked it way out of solution. Look
Dip-
at that.
dip
Look,
in-
oh, look. Get right in. See it?
Oh, yeah.
See it clear, and then the...
Dip into it with your spatula.
Handy dandy spatula.
Okay, so watch this, guys. Look at that.
Wow, well, it was nice and uniform, and now
Uniform.
it's all
Kluggy.
okay.
And you can see the watery part, like the yeah,
Yeah, the solvent on
the
top.
solvent on top, and then this
Well, keep it
stuff.
mixing for a while, see what happens.
Okay.
Hope it doesn't overflow.
It might overflow.
Might want to put it down a little bit then. Hang on to it.
Okay, I'm hanging.
Okay.
Okay.
Alright, here, let's, okay, now do it. Okay, I'll try to get it all blended in.
As best as possible. It's better, but it's not.
It's a non-solvent. It's trying to dilute itself in.
And by diluting itself in, it's crashing up.
But we'll try to make a drawdown on this just to see what the effect of the drawdown is.
Okay. So now since I added it, I will check up.
So I guess this shows we don't add mineral spirits to acrylic resins.
I guess not.
However, the next experiment shows that maybe there's a way we can recover it.
Oh. I'll bring it back.
Okay, let's take 10 grams from this.
Okay. Look at that.
Okay,
that
so
cool.
you're putting in the...
Look at the web. Sorry. Yeah, see, if you pour it in, it'll just be the solvent, but I want some of the resin in too, so I'm scooping it out. But it's all... Ooh,
Okay, there's your
10.2.
10 grams.
Okay. Get back in. It's all web-like. It looks cool.
And that was caused by the solvent.
Yeah, that's caused by the mineral.
Okay, so we'll put a slower
Water.
evaporating solvent in now
No,
and
screw
see if we can fix it.
Let's hope to fix it.
Did you label that container?
I'm going to.
Should always label it first.
Oh. Okay, I'll remember that for the next time.
I think I told you that last time.
I had total plans to label it, but things got in the way. I wanted to pour it in.
Mm-hmm.
Solvent.
How are you going to get your A? Because you're cute?
Yep.
Okay.
It works. Okay, so see there's 17G
17G, okay.
right there.
We got F, we got G. Now all we need is H. You got 90 grams here.
90 grams, so we have check.
Actually, you don't. You have 100, don't you?
Yeah.
So put plus...
No, 110. I just took out 10.
Yeah, but see here, 90 plus 20 added up to 110.
Oops.
So you took out 10. So you just put plus 10 there because it doesn't matter. Okay,
Okay.
good. Now we'll add the 20 grams of a very slow evaporating, and you can probably add it right on the balance there. You don't need to do it under agitation.
Oh, cool. Why not?
Because it's already dissolved.
Oh.
It's the agitation. What you don't want are the granules to be crunching up with each other and forming great big chunks.
That's good. Okay. So there is going to be zeroed. And so now we'll add our DPNB, which is right here, and I should relabel it. The P looked like it was getting worn out from constant use of solvent. There. Okay, so DPNB, which is...
It's a child-proof cap. You might not be able to open it.
What was that? I don't think you could open it. Let alone me. Okay, so 20 grams of this child-proof cap. Let's see here. Like this?
There you go.
32. There's going to be 10. There's going to be 20 almost. Okay. 20!
Excellent.
Plus, I think I spilled a little. Hold on. Here, Dad, try to get this off. Okay, so, hold on. I might have gone 1 gram over, but 20.9.
Okay, just write down your excess.
Yep. 0.9 plus 20, and I added it. So see, I don't get my A just because I'm cute. I get it because I work.
Good for you.
Okay. So
Now let's mix it up and see if it goes back into solution. Mix it up on the blender here would work.
It'll work faster. It's already going a little.
Hey, very good. Hope it doesn't overflow.
Yeah, so it's 9.
Push it clear to the bottom. There you go.
See, it already helped it.
Great.
It's 907. Take this and just get the heavy resin from there. Yeah, look at that now. It's working.
Well, I hope it fixes all the rest of the parameters.
Yeah.
Okay, so let's prepare. Well, as soon as this stirs in, then we'll prepare for the drawdown. Okay, so let's put on some gloves. Good.
Gloves are required.
All right.
Okay, so right now this one's going to be solvent 17F, solvent 17G, and solvent 17H.
And what's the date?
Today's date is 2/18/2014. The time is 8/9/12.
Okay, applicator is 003. Good, you're ready.
Great. We are ready.
Ready to lock it into place?
Roll. Yes. So let's
Show
get
me your
tape.
applicator there, please.
This is the applicator at the drawdown bar.
Drawdown bar, it's clean.
It's all clean.
It's got-
It's all shiny.
The reason it's called 003 is 3/1000ths of an inch.
That's cool.
It's also called 3 mils.
See, we're taking a tape like this. That was my pen. It's okay. So we're making sure that it little hangs over the edge. Just a bit. We're securing it. There. That's fine.
Need some catch paper.
Yep. Just thinking that same thing.
This is really not far enough over the edge.
Sure?
Well, it might be. Okay, it might be.
Okay. It's barely, but it is. Catch paper.
There's a phone book right there.
Phone book, I found it. I mean, you found it, but I was the second one to find it. Okay. I didn't do it. Okay.
Usually the thin paper there.
Catch paper.
Okay, yellow pages, good. Lift up on the glass.
And put it under.
There. Now, why do you suppose it's called catch paper?
Because it catches the excess.
Good.
I learned that one. Okay, so here's the 17F. Put a little bit right there. About like that. I have gloves now. 17G, if I could get it to pour.
You might have to use a stick.
Hold on, it's coming. It's a coming.
Here's the
Ta-da, look, it's a coming.
stick.
There's 17G.
Try to put it so they touch each other. Make it big enough,
Okay.
close enough. Okay, you got it. Good.
Oops, it's wiping out 17G. And then here's the lightest one. I'll be using a clean spatula to put this one on. See, look at that solvent work. There we go.
Well, we can tell that mineral spirits was the wrong solvent for the job.
Yeah. Okay, so now that they're all there,
I put this up there so you won't bump it into the floor.
that's a smart move. Okay, so now I will put it like so. And did I put, yeah, put enough 17 each. And draw it down. Got it.
Great.
Wow.
Okay. Well, that's our drawdown. We don't know exactly how long it's going to take to dry, but we got the time there, 9:12. And I'll come back and check it later.